In this video, we're going to be discussing interest rates with different compounding periods. And to start that off, I'm just going to give you an example. Let's say that you had a loan that was, maybe just 1 year in length. And maybe you had a interest rate at 8%. Oftentimes, these rates are going to come with a compounding period. So let's say the compounding period was quarterly. So we could say that this was compounded quarterly. I'll write that here on the top. What that means is this rate is going to be applied 4 times each year, but not 8%. 2% is actually what is going to be applied. So let's say that it was for maybe $1,000. We'll just go with $1,000. So if we use our knowledge from the previous video on growth, we would see that we've got this ending amount equal to some starting amount, which we call the principal. And that's 1, this is going to be growth, okay? You're going to be increasing your money, or at least the money you owe in this case. And then that's going to be raised to the t power. Now that works great, except with this whole compounding thing. Because actually what we need to do is we need to take $1,000 and we need to multiply that by 8 divided by 4, and it's going to be 1 plus that number. So it's actually going to be 1.02. So 8% would be 0.08 divided by 4. Again, we're compounding quarterly. And what we're going to do is we're going to have to multiply 1,000 by 1.02, and that'll be the first quarter. The second quarter, we're going to take this whole amount and multiply it by 1.02. And then that's at about half, or 2 quarters, and then we're going to have to do it by another 1.02 and another 1.02 after that. And that'll be the rate of 8% compounded quarterly. So you can see that this 1.02, that would all add up to be 8, but it's being applied 4 times because there are 4 quarters in 1 year. If you went ahead and did that math, you would figure out what that would be, and it wouldn't be just 1,000 times 1.08. It would be a little bit more than that. As a matter of fact, let's go ahead and do that real quick. So I've got my calculator here. Hopefully you all can see that. And it's going to be 1,000 times 1.02 times 1.02 times 1.02 times 1.02. And that's going to be 1,082 and then 0.43, and that's going to be the money that you'll have in your account. So if this interest rate was applied just 1 time, then 8% of 1,000 would be 80, and you'd have 1,080 in your account. But the power of compounding is that actually you'll end up with a little bit more because the rate is being applied, or at least the rate is being applied more than just 1 time. If we look at this equation here on the left-hand side, this would be really good if we didn't have this compounded quarterly thing. And I want you to look at this 1.02 and the structure of what's happening here. And actually, if we rewrote this expression here, and we rewrote this with an exponent, well, this would be 1.02 raised to the 4th power. There's 1, 2, 3, 4 of those being multiplied. So you might be asking yourself, hey, the time is only 1 year, and the rate is 8, or 0.08. How do we get from this to that? Well, we need to write a new equation. And so this new equation is going to be, we'll just use A. So this is going to be the compounding equation. So we'll start with some of the formula here. A is equal to, or the ending amount, the principal times 1 plus, and then in this case it's not 8%, it's actually 8 divided by 4 because we're compounding quarterly here. So what we're going to do is we're going to take this rate and divide it by some number n, and n is totally related to this compounding period right here. You can compound quarterly, semi-annually, annually, monthly, daily, by the second, I suppose, if you really wanted to. But basically this number n here is how many compounding periods fit into 1 year. Also up here on the top, remember that n would be 4 for this case. We don't have just 1. You know, the time would normally be just 1. We actually have 4, or 4 times 1. So we need to write an n and a t up here on the top. So let me go ahead and I'll just give you what all of these variables mean, and go ahead and that was kind of our example examining what's going on here. And then over on the right hand side we'll just say A is the ending or final amount. Define these variables for you. And then P is going to be the principal, or this is the starting amount if you want. So if you're talking about a loan, the loan would normally be for a set amount, and then you're going to have interest on top of that. So this is the principal or starting amount. R is still the rate, and that's going to be in decimal form. And then n is this funny number, and n is very much related to the number of compounding periods, so we can say that n is the number of compounding periods in 1 year, just in 1 year. And let's see here, t then, maybe we have to move this up just a little bit. T is just going to be the time, and this one is definitely going to be in years. So this is the equation that you want to remember here, the compounding equation for different compounding periods and interest rates. And you can use that with whatever loan you have, and this is especially important in the financial area, definitely. There's one other one that we need to talk about as well, so I'm going to go ahead and do this on a different sheet of paper. I think I'm running out of room here, but you can write that down on your notes. So the other one is this, and so I'll put a little star up here on the top, and this is going to be continuously compounding. I hope I've written continuously down correctly. Continuously compounding. So if we look back over here, we can see that the this loan here, our example, was compounded quarterly, and you can do this and with this equation here, and you can do this for just about any compounding period you want, except for something that's compounded continuously. So the smallest fraction of a second that you could ever imagine, let's say that rate was being applied. What you would have down here in the bottom then, the number of compounding periods, if this thing was compounded continuously, well, that would be infinity. There would be an infinite number of them. And then infinity would be up here, and we just really don't know how to deal with this whole setup with our given equation here. We need a new equation, and so the new equation is A is equal to P, same variables as before, and this funny number E. And E is it's a constant, and I'm going to write here also has an exact value. Now it turns out that this is an irrational number, so you can't write E as a fraction, but it is an exact number, just like pi. So let's see, it's constant, and this will make all go up here with E, and has an exact value. And there's a button for that on your calculator. So if you take a look, this is just a TI-84. Take a look at your calculator. You're going to have to hit second. I'll turn the calculator on here. Second, and the division sign you can see in blue right there is a little E. And if you hit enter, you've got the approximation of E, and it kind of looks like it repeats over here, but it actually does not. If you were to extend this decimal off to the right hand side, you actually wouldn't see anything repeat. And so it's about 2.7, 2.72, somewhere in there. But your calculator has that value stored for you, so it's often a very good idea, instead of using an approximation, to use E. Also, we need to raise this to the rate times the time. So here, because we're compounding continuously, you don't see any n. E is kind of taking care of that continuous compounding. If we apply this to our last example, remember that if we didn't have any compounding, the value of this loan here, or bank account, or whatever it is going to be 1,080. But we are applying the rate of 8% a little bit differently, and we actually end up with a little bit more money in the banking account. So if we did this continuously, so let's go ahead and write our example here. So for just an example, we've got a 1 year, and this could be a loan or savings account or whatever, and it's for $1,000. And we're wondering now, and the rate was 8%. We're wondering if we compounded continuously, what would happen with this? Well, let's see. We would have A is equal to P as the starting amount, or 1,000, times E, and then we need to raise this to the rate, which is 0.08. Always change the rate, if it's a percent, into a decimal, times T, and that's times 1. So if you enter this into your calculator, all you really need to do is just type in 1,000, second, the division symbol, which is the E, and then we're going to raise that, and it's a really good, in this case it really doesn't matter, but it's a good idea to use parentheses, and actually I don't have to do that on this calculator, because it actually raises it up in the superscript position there. But we could do that. You're going to need to do this definitely on the older versions of some software that you have with TI-84s. We're going to do 0.08, and then you could do times 1 if you want, but you really don't have to in this case. So that's what we're going to do. And we're going to see here that we've got A being 1,083, and you have a choice here whether you want to round up or down. So if you have this as a loan, the bank will probably round up. Although if this is a savings account, the bank will, you guessed it, round down to 28, because they don't want to pay you any more than they have to. But let's say this is a loan. So we're going to go ahead and round up, and so the total value there would be 1,083.29. So if we compare these, we can take a look. Remember, if we didn't have any compounding, if we just applied the rate once, we'd have 1,080. If we compounded 4 times per year, or quarterly, we get 1,082.43. And then if we compound continuously, we get even more money, 1,083.29. So compounding is definitely your friend.